And this represents a 23% increase. We weren't too happy about that. I'm sure you're not terribly excited about it either. The board, in starting the discussion about what to do about that, realized that the weekly cost affects a bigger picture of how lunch fees, dues, and the pro forma budget are interconnected. Lunch is not just a matter of where we eat, but the revenue involved in that. Such lunch fees are a substantial expense to members. They also represent an essential element of our revenue for this club. Specifically, lunch funds are the cost you pay or the fee you pay doesn't just go to lunch. It funds our administration costs and supplements many of the community programs we value, such as the dictionary project and the mini grants. So as you can see, they are connected and not just simply the food or the location. Have you got number 2, please? We discovered in this discussion that on average, 45 to 50 members do not attend the lunch meetings. Many members are either exempt from paying a makeup fee because of their membership status, or they qualify for a makeup in some other way. For example, the membership committee attends a standing meeting once every month, and by participating in that meeting, they're exempt from having to pay one makeup fee. Non-attending may be a valid thing, but it still represents a noticeable loss of funds to the club. So even though it's valid, even though it's justified that you don't attend lunch, and we accept that, we support that, it does reduce the amount of money that we bring in. Number 3, please. The board developed a new structure that we believe is fair to all concerned. This new structure, as you can see from the graph, increases the annual dues for every member, including those who do not attend and those who do not eat. Those members who attend regular meetings or for whom makeup fees are assessed will pay a lower overall cost under this structure. They will pay an increased annual due. We will all experience an increase in the annual dues, but this will be across the board. Weekly meetings are an essential part of the Rotary culture, and the shared cost of these fixed expenses is fair to all concerned. And the board, after a great deal of debate and discussion, decided that this was the most fair structure that we could come up with. And this is why we adopted lowering your weekly lunch cost and increasing your annual dues by $120 for everyone. This will allow the committee to deal with the facility without having to tie the cost of the lunch to that facility directly. So it gives us a little flexibility, in other words, in what facility we choose. A facility should really be meet our needs, and we shouldn't have to just pay for it and collect that from each of the members who attend. Are there any questions?
Let me save questions till after the meeting. You guys please remain here because we're getting tight on time.
Okay.
Yeah. Thank you very, very much.
Okay, next week we'll have our District Governor Joe Hamilton and his wife visiting at the Martinelli Center. And I think you're familiar with his wife, Kelly, or Kathy's wishes for a project that we usually do things in a different way. When the governor comes to visit us, we hand him a gift, and he hands us a gift from the last club that he visited. His wife might do something different this year. I think you've heard about it a couple of times. She would like to have us donate little baby blankets called receiving blankets. She's evidently connected with some hotels that told her that with the cutback on the economy and so forth, they have not been able to send those kids home on something that is their own. So we are asking for donations of either go out and buy one of these blankets, or you can today, we're going to pass the hat. And here's the reason. The ladies love to go out and shop, and they probably would. The guys don't. So I'm asking that primarily the guys at the tables go ahead and donate to that hat. Why don't we get it started? And see what we come up with, and then we'll ask one of the ladies to go out and buy stuff for us.
Dr. Robt Piccioni, today's speaker. He is a graduate of Caltech and got his Ph.D. in physics from Stanford. And he has also taught at Howard and other universities. He has run 8 different high-tech companies and has several patents in the medical field and the smart energy field. He is now, doesn't look like he's very retired, but he has also written 5 books. He teaches at UCLA and at Cal State Channel Islands. Please welcome Dr. Robt Piccioni.
Thank all of you. How's the sound? Good. Thank all of you very much. Before I get started today, I'd like to know by show of hands how many of you are great musicians. In doubt, cut yourself a break. And how many of you, by show of hands, love great music? Everybody who can still hear. So I think we're all agreed then that anyone can enjoy music even if you haven't devoted your life to making music. And I think the same idea applies to science. I think everyone can enjoy the exciting discoveries and the intriguing mysteries of our universe even if you fear physics and are allergic to math. Any of those here? And I want to demonstrate that notion by discussing with you today the true story of the most famous scientist in history, Albert Einstein. Now, Einstein was chosen by Time magazine as being the person of the 20th century. I mean, really, can you believe that? Of all the billions of people that lived in the 20th century, they chose a physicist as the person who had made the most important contribution to mankind, saying that he had the greatest mind and was the paramount icon of our age. And indeed, his name has become synonymous in our language with the word genius. So one might well imagine that Einstein's life was a bed of roses and endless sequences of accomplishments and accolades. But the truth is actually much more interesting than that, because hardly any human being in history has failed more often and overcome more rejection than did Albert Einstein. And it all started out bad from the get-go. He was very slow to learn to talk. He got nicknamed Little Dopey. He was then expelled from the 2nd grade for being inattentive, and the headmaster sternly declared, "This little boy will never amount to anything." He dropped out of high school in the middle of his sophomore year, tried to get into a lower-level college, but failed the entrance exam. He eventually did manage to get in, and he did graduate, but with the 2nd worst grades in his class. And along the way, he even failed a course in physics, and he had made a point of publicly insulting all of his professors. So with very poor grades and horrendous references, Einstein was the only member of his graduating class who couldn't get a job. He applied to every university and technical institute from Norway to Italy, and he was summarily rejected by every single one of them. He wasn't even offered a single interview. Finally, during this period, he was being supported by wealthy relatives, otherwise he would have been living on the street. And finally, the father of one of his friends, who had a lot of juice in the Swiss government, managed to get a new position budgeted in the patent office. And the job description was written with Einstein's credentials in mind. Or should I say, Einstein's lack of credentials in mind. Well, Einstein figured this is a setup, a slam dunk, all I have to do is show up, but he failed the interview. So Albert Einstein was rated technically unqualified to be a government clerk. Fortunately for science, the search for competent civil servants was trumped by political influence. And Einstein was hired even though he was unqualified for the position. Now, of course, that would never happen in our society today. Well, it was a minimum wage job. It wasn't paying enough for him to marry the love of his life and start the family that they wanted. So Einstein submitted a Ph.D. dissertation to the University of Zurich. And in his dissertation, he detailed exactly why the theories of the leading physicists of the day were all inane. Somehow these people managed to reject his thesis. So largely through his own actions, this young man had firmly placed himself on the road to failure and obscurity. And it seemed he would fulfill the prophecies of his many detractors and never amount to anything. But Einstein had one quality in great abundance that I think is the most important ingredient to success in any field of human endeavor, and that is he had tremendous persistence. The man simply never quit trying. I think all of us and all of you Rotarians can relate to that quality. Asked later in life why he had succeeded where so many scientists had not, he said, "It's not that I'm so smart, it's that I stay with problems longer." In other words, he never quit trying. Einstein could work on a problem virtually night and day for 10 years or more, even if there was no apparent sign of success, and he simply wouldn't give up. And because of that, he ended up solving some of the most difficult problems in the history of science. Now, imaged over here is a picture of Einstein's laboratory, and every instrument that he used in his life is sitting on the top of that table, a pad of paper and a pen. So this, the most famous scientist in history, never did a single experiment in his entire life. He never made a serious observation or measurement, and everything that he discovered came completely from his own thoughts. You've heard my talk before. And by avoiding real laboratories, Einstein was able to avoid a lot of the hazards that most scientists face every day, like high voltage shocks, liquid nitrogen burns, exposure to ionizing radiation. In other words, all the things that have made me the man I am today. Well, in 1905, a lot of these ideas that Einstein had been working on for 10 years or more gelled, and he published 5 spectacular papers that completely revolutionized science and solved all the open issues of the day in physics. And this is therefore called Einstein's miracle year. In my opinion, any one of these 5 papers could have won a Nobel Prize, and no scientist that I know of has ever published even 2 such papers in a single year. Well, naturally Einstein figured now his life had to be set. I mean, after all, what more could he do than revolutionize all of science and solve all the open issues? So he sat back and he waited for universities to beat a path to his door with glorious job offers, and nothing happened. No one called him up to say that was a great paper. No one called him up to say, give us a talk and explain this relativity stuff. And most importantly, no one called him up to say, come work at our university, we will pay you. Years went by. He did manage to get his Ph.D. for the least revolutionary of these papers, but no jobs. And finally, after 2 years of frustration, he applied to become a high school physics teacher. And he was rejected. It took 4 years after his so-called miracle year before this became a miracle for Einstein. And in 1909, he got his first small measure of professional success, an appointment as a junior faculty member at the University of Zurich. The man is now 30 years old, and it could be fairly said that he had failed at everything that he tried to do every day of his life until the age of 30. And a lot of people would have quit long before then, but only because Einstein never gave up do all of us know his name today. Well, from his first job, he started climbing the academic ladder, and within 4 years, the most famous scientist at the time, Max Planck, said of him that there was hardly a major problem in physics to which Einstein had not made a remarkable contribution. And based on Planck's strong support, Einstein got the best job in the world. It came in 3 parts. First of all, he was made immediately a full professor of physics at the University of Berlin, with the promise he would never have to teach a class. That's what the best professors get, by the way. Second of all, he was made a director of a new institute of physics with the promise that someone else would take care of all the administrative duties. Third, he was made a full member of the Prussian Academy of Science with the promise that they didn't expect any work from him in that position either. So they gave him a very nice office, 3 full paychecks every week, and said, would you kindly just sit and think, and if you come up with something nice, would you please let us know? Such a deal, right? I'm sorry to tell you that position is no longer available. Well, and finally, Einstein received the highest accolade in science, the 1921 Nobel Prize. So let's talk next about some of the things that this famous man discovered. Well, one of his discoveries was that atoms really do exist. Now, people had been arguing about that for 25 centuries. It was the longest running debate in the history of science. And in 1905, Einstein provided the definitive method to prove that atoms really do exist. Now, with our most advanced technologies, we can actually image individual atoms. Each of these blue dots is a single xenon atom, imaged by an atomic force microscope in the central research labs of some very large, famous international corporation who's not paying me to mention their name. Einstein also solved the mystery of the photoelectric effect, which is the basic technology for the operation of solar cells, for the CCDs that are in all of our digital cameras, video cameras, and in all TV studio cameras, and also the imaging devices in all modern telescopes, including the Hubble Space Telescope. It's also Albert Einstein who developed the theory for the development of lasers. Lasers are nearly ubiquitous in our society. They sculpt our cornea, they scan our barcodes, they read our CDs and DVDs, they carry our internet and telephone communication through fiber optic cables around the world, and they are the core technology in countless pieces of medical equipment, industrial equipment, military devices, and my little pointer. And if you get to where you want to go with your car navigation system, you should thank the man who can never find his own keys. Because without Einstein's theories of relativity, the GPS system would be worthless. It would have a cumulative error of 6 miles per day, which means if you got home on Monday night, you'd be in the wrong city on Tuesday night, and by the end of the week, you'd be out in the ocean. Einstein also made essential contributions to quantum mechanics that led to solid-state physics and the development of all the digital devices that we have in computers, iPhones, iPads, and all of the other toys that we didn't have 20 years ago but somehow can't seem to live without anymore. And finally, Einstein's most famous equation, E equals mc squared, was the basis for the development of the nuclear weapons that ended World War II, is the basis for the operation of all nuclear power plants that exist today, and will be, as we'll discuss in a few minutes, I believe, the basis for the development of much smarter ways of making energy. Ways of making energy that are vastly cheaper, vastly safer, much cleaner, and unlimited in their abundance. But the one thing that Albert Einstein never was able to discover was the comb. Okay, let's talk about his most famous equation. This equation tells us that mass and energy are really equivalent to each other. So the mass in this pointer, the mass in my hand, the mass of the Earth, everything that contains mass, Einstein said, is really a condensed form of energy. That's what we all are. Now I think probably everybody has seen this equation at least once in their life. It's on coffee mugs, it's on t-shirts, God forbid you might even have seen it in a physics book. But possibly not all of you would be comfortable explaining to your children what this equation means. But actually, I think everybody in this room already understands the principle behind this equation. You understand the principle behind this equation in a different context, and that's the context of money. Not everybody likes numbers, but if there's a dollar sign in front of the number, most of us will perk up, right? Most of us are pretty good with money. And what Einstein is saying about mass and energy is what all of us already know about money. We all know that money comes in many different forms. There are dollars and euros and pesos and yen, and that's all money. And we know we can convert one form of money into another form of money. And that's what Einstein is telling us about mass and energy. So if we were to, for instance, fly to Japan, we would need to convert some of our dollars into yen, and the procedure is pretty straightforward. You take the number of dollars that you have, you multiply by some exchange rate, and that tells you how many yen you're going to get. So Einstein's equation is saying the same thing about mass and energy. He's saying you can convert mass into a different form of energy, such as heat. The amount of mass that you want to convert, that's the M, times an exchange rate, tells you how much energy you're going to get in the other form. So the exchange rate, Einstein said, is c squared. C is the speed of light through empty space. It's the fastest that anything can move. It's a very big number, 671 million miles per hour. C squared is c times c, so that is a very, very big number. And so Einstein is telling us that even a small amount of mass times this stupendous exchange rate is going to produce a huge amount of energy. So just how huge? Well, if you took all the mass energy in a single US penny and you converted it into useful work energy, which we will one day be able to do using Einstein's equation, you could supply 1 billion people with all the energy that they need in a day. Or equivalently, that mass energy in a penny equals the amount of chemical energy we now get when we burn 2 million gallons of gasoline. 2 million gallons for a penny. Anybody think we're paying too much for gas at $4 a gallon? So let's take this idea and let's apply it to a problem that's critical and facing our society today. How are we going to generate all the energy that our citizens need and want without destroying the planet and without bankrupting our economy? We are spending trillions of dollars a year on energy. We are generating fabulously large amounts of pollution by using 19th century technology to generate that energy, and that pollution is poisoning our air, our water, and our soil. So we simply have to find ways of doing something better, and fortunately there are some good options. Now the problem is, all the residents of the United States in a recent year used a total amount of energy in all the different forms that amounts to 25 trillion kilowatt hours. And that turns out to be as much energy as you would get if you converted 1 ton of mass into useful work energy according to Einstein's equation. So the problem we face, and the most insightful way to think about it, is how do we best convert 1 ton of mass every year into useful work energy? What are the options? Well, we can burn coal. If we got all of our energy from burning coal, it would take 5 billion tons of coal. If you carefully weighed everything before and after, you discover there was 1 ton missing at the end. And it's that 1 ton that's missing that got converted into all the energy that we wanted. That's what we wanted to get, but we had to buy 5 billion tons of coal to burn it. And in the process of burning it, we have created 5 billion minus 1 tons of pollution. Everything that didn't become energy becomes pollution. What else can we do? Well, gasoline's got more bang per pound than coal. We would only need to burn 2 billion tons of gasoline, not gallons, this is tons. Again, 1 ton would become the energy we need, and all the rest of it would become pollution. So why is it that with all the clever scientists and engineers in this world, we can't do a lot better than that? Well, the answer is, it lies in the atom. Atoms are very simple. They just have 2 little parts, an inside and an outside. And the inside is the nucleus. The inside has 4,000 times as much mass as the electron cloud, and millions of times more energy. So when we burn coal and gas, or this process combining hydrogen and oxygen to make water, what we're doing is we're not changing the nuclei, which have all the energy, we're just rearranging the electrons, which have almost none of the energy. So we get a sliver of the energy that the electrons have, but we don't get any of the energy that's stored in the nuclei. So if we want to be much more efficient, if we want to have cheap and clean energy, then we need to go to where nature put the energy. And nature put the energy in the nucleus. There are 2 ways to get energy out of a nucleus. You can make it bigger, and you can make it smaller. Peter will tell you nuclear physics is really complicated, right? But that's the only 2 things you get to do. So nuclear fission is making it smaller. The good news here is this is 100,000 times more efficient than burning coal. The bad news is the end products of nuclear fission are radioactive. So if we got all of our energy from nuclear fission, we would need to burn 50,000 tons of uranium every year. That's 100,000 times less. But we would be left with 49,999 tons of radioactive waste. Now, we had a plan for that. We were going to bury all that in Harry Reid's home state. As long as he's running the Senate, that's out. So the other alternative is nuclear fusion. This is where you take small nuclei and merge them to make, together to make a bigger one. The good news is this is 40 million times more efficient than burning coal. 40 million times. The other good news is no radioactive waste. The end products of nuclear fusion are helium, a perfectly clean inert gas, plus carbon, oxygen, nitrogen, and iron. This is not radioactive waste. These are the atoms in our bodies. These are the atoms that life requires. And in fact, it should come as no surprise to any of us that nature knows how to do this right. In the center of every star in the universe, nature is producing fabulously large amounts of energy through the process of nuclear fusion, energy that supports life on Earth, and in the process, nature is creating all of the carbon, all of the oxygen, and all of the other elements that life requires. When those stars come to the end of their lives, they cast off their outer layers, and the atoms that are produced in the center of those stars seed gas clouds that collapse and produce future generations of stars and planets, and ultimately us. So nature is an efficient recycler, and nature does not pollute. Every carbon atom in the universe was created in the center of a star at temperatures of hundreds of millions of degrees, and 90% of the atoms in every one of our bodies were created in stars, and then recycled through the cosmos when those stars die. So we truly are made of stardust. And that twinkle in your loved one's eye, that truly is a little bit of a star. So if we learn to do what nature does, we would only need to burn 133 tons of hydrogen every year, and on that scale, the universe has the ocean has an unlimited supply. We would get our 1 ton of energy, just like all the other alternatives, and we would be left with 132 tons of clean helium gas, which we could fill party balloons and blimps. And people have been working on this for about 50 years. One of the leading projects for doing this is just a few miles away at the Livermore Lab. And there is another very interesting and unique idea that's come up by a small private corporation in Chicago, which I think they have about a 50-50 chance of making a commercial device in the next 5 years. So that would be the biggest revolution in energy production since mankind invented fire. So let me conclude by saying that because he never gave up, Albert Einstein revolutionized mankind's understanding of atoms, light, gravity, mass, motion, space, time, and even our notion of the universe and our place within it. And that's none too shabby for a guy that no one wanted to hire. Okay, we sort of ran out of time, so I'll stay around and ask questions in the back. Let me introduce my lovely bride of 43 years, Joan. And Joan is my chief financial officer, so she's got all of my books, and if you want to pay retail, you can buy those on Amazon. If you want to pay half as much, see Joan. Thank you very much.